Hello, and welcome to Backer Breaks It Down. In this episode, we are solving trig equations using identities. That's right. So sometimes you have to rewrite a trig equation in order to be able to solve it. So let's talk about, sorry about that. Let's talk about such problems. So the identities you'll have to use, like sine squared, can be replaced with 1 minus cosine squared. Cosine squared can be replaced with 1 minus sine squared. If you have any double angle identities, so 2 times an angle, sine of a double angle can be replaced with 2 sine cosine. Cosine of a double angle can be replaced with either 2 cosine squared minus 1 or with 1 minus sine squared. How do you know which one of these to use? Well, you have to look at what the rest of the equation looks like. Okay, so let's take a look at 2 examples. So number 3, we have cosine of x minus 2 sine squared x plus 1. I can't do anything about cosine. There's no rewriting cosine when it's all by itself. But I can totally rewrite sine squared x. And so that is what I did. Okay, so I know that sine squared x is equal to 1 minus cosine squared x. I'm making that substitution. And now look at this equation. It's all cosine, which is totally what I wanted. Let me simplify it. Okay, so here I distributed and then I cleaned it up. So now I have 2 cosine squared x plus cosine x minus 1. So now it looks like a problem from our previous video. You know what that means? It's time to factor. So remember, it can be helpful to rewrite it in terms of x and then do your factoring. Here's all my work. And I got that 2x minus 1 times x plus 1 are the 2 factors. Bring back the trig being cosine. So really my 2 factors are 2 cosine x minus 1 and cosine x plus 1. You know what comes next? The zero product property. So set each of these factors equal to 0 and solve for cosine. So I did that, look. So 2 cosine x minus 1 became cosine of x equals 1/2, and cosine x plus 1 became cosine of -1. So then it's where are the solutions? Well, cosine would be positive 1/2 in quadrants 1 and 4. Cosine would be -1 at a quadrantal angle. Yep. We haven't seen that yet, have we? So you know what that means. Now that we know where are the solutions, we can finally find the solutions. So let's start with that quadrantal angle because there's really not a lot of work there. But we have that cosine x is equal to -1. Well, remember, when it comes to our quadrantal angles, cosine is the x value. So do you see where your x's are equal to -1? Bing, 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 right here at pi. So the answer to this part of our equation is just pi. Cosine of 1/2. So if I keep it simple and draw myself a little reference diagram in quadrant 1, cosine's the adjacent over the hypotenuse. Now check out our reference angle diagrams. I'm seeing that right here at 60 degrees. And we already said that our answer is in quadrant 1 and in quadrant 4. So our 2 answers here are pi over 3 and 5 pi over 3. So we have 3 answers total because in addition to the pi over 3 and 5 pi over 3, we also had pi. So these are your 3 solutions. Let's check out one more. Cosine of 2x plus 3 sine x minus 2. That cosine of 2x must be dealt with. And there are 2 ways that you can deal with cosine of 2x. You can use that it's 2 cosine squared minus 1, or that it's 1 minus 2 sine squared. Which one would be better here? If you look at the rest of the problem features sine. So we should probably go with the 1 minus 2 sine squared here, right? So then everything is in terms of sine. So let's check it out. So that's exactly what I did is I replaced cosine of 2x with 1 minus 2 sine squared x, and then I'm going to clean it up so that I get -2 sine squared plus 3 sine x minus 1 is 0. You know what time it is. It's time to factor. So I'm going to rewrite it so that it's x, makes it easier to factor. I'm doing my factoring, and then I'm bringing back my trig. So I have, for my factored trig form, -1 times the quantity 2 sine x minus 1 times the quantity sine x minus 1. So then it's time to use the zero product property and to isolate the trig function. So 2 sine x minus 1 becomes sine x equals 1/2. And sine of x minus 1 becomes sine of x equals 1. So then it's time to be like, where are the solutions? Well, sine would be positive 1/2 in quadrants 1 and 2. Sine would equal 1 at a quadrantal angle. So then it's time to figure out what are the solutions. So we can start with the quadrantal angle. Okay. Sine is equal to 1 at a quadrantal angle. The y values are sine. So look and see, where is sine equal to 1? And it's equal to 1 right here at pi over 2. So that means in this one that x is equal to pi over 2, and that is one of our solutions. For sine is equal to 1/2, I'm going to draw myself a reference triangle in quadrant 1 because I'm keeping it simple. Sine is the opposite over the hypotenuse. Now look for that reference angle below. Ah, here it is. It's a 30-degree reference angle. And we have already said that sine is positive in quadrants 1 and 2. So that means x is also equal to pi over 6 and 5 pi over 6. So we have a total of 3 solutions: pi over 6, 5 pi over 6, and pi over 2. So this is how identities are used in trig equations. Basically, you can replace sine squared, cosine squared, sine of a double angle, and cosine of a double angle with something else, so that your function, or your equation, I should say, is all in terms of one trig function. And then from there, you can factor, use the zero product property, find out where your solutions are, and then finally find what your solutions are. And that's how Backer breaks it down.